Okay, now the next thing we're going to review on this final is inequalities. So I want you to tear this sheet off because we're going to be referring to that as we work our way through this review. Okay, we have a number line. We have to write an inequality for each graph. So we have 3, a circle closed above it, and then everything this way, which would be 4, 5, 6 greater than 3. So you use a variable to represent all the possible values. So x, and then you put 3. So headed that way, that's obviously the greater than, which is this sign right here, greater than. Okay, since the circle's closed, you put equal to. That's it. Okay, next problem. Now we're at -5, but we're going this way. That's less than. So you put x first, then the number value that you're above, okay, and you're going less than. So that's this one right here. Less than. That's a less than sign. Okay, now x can be any number as long as it's between -3 and 5. So what I do is I put an x, okay, I put -3 and I put +5, okay. Now when the solution set is between two numbers, like I'm exemplifying here, you want to use two less than signs. Basically you want to eat the highest number, but then you eat the x, okay, and that's how that's always labeled when it's between. Now since the circles are closed, you put equal to right there. Now the reason why they're less than, don't write this down, I'm just showing you why. Pick a number between -3 and 5, let's say 1, okay? So I'm going to replace the x with 1, don't write this down. Well, 1 and -3 would eat the 1, 1 and 5 would eat the 5, that's why they're always double less than, like that. Okay, now when the solutions go infinitely outward in both directions, outward, okay, you write the word or, and then you just label them separately. So x10, so that way is greater than, okay. x2, that way is less than, okay. Or just like that. Greater than this way, less than that way. Okay, now the next problem, we are solving the inequality. We are graphing your solutions. You need to label your graph. Okay, I'll explain what that means. Now you're finding all possible values for x. See, yesterday in the last test, you were solving equations where it said equal, so there's only one answer, okay? But with greater than and less than, there's an infinite number of answers, okay? We got to find where it starts and which direction it would go. So use a number line to convey our solutions, okay? So we need to graph that. Now, you circle the inequality. If there's only one, your job is to get the x by itself. Now, one thing you have to pay attention to, the sign is going to switch if you divide each side by a negative, if you multiply each side by a negative, or you have to reorder at the end. The x at the end has to be before the number, okay? Okay, why do you have to flip it when you divide by a negative? Well, if you divide both of these, so 20 and 10, it eats the 20, okay? If you divide them each by 4, okay, you'd get, or actually I'm going to make that a 5. I'm going to divide by 5. 5 and -5. If I divide by 5, this becomes a 4. 10 divided by 5 is 2. Well, it would still eat the 4. It would still be a greater than sign. But if you divide them each by -5, you get -4 and -2. Well, now the sign would have to eat the -2. It would become a less than, okay? So when you divide by a negative, the sign has to flip. So if I have x on one side with no parentheses, I'm going to mark my operations, and I know exactly what I'm going to do. I'm going to -1 first, but the sign never changes when you plus or minus. That doesn't affect the sign. Now I'm going to divide, but I'm going to be dividing by a positive, because 2 is positive, so the sign doesn't switch there either, okay? If that 2 is negative, I'd have to switch it. So I kind of like to fill in my signs. Now I execute the steps. -1, -1, so 2 times x, -4, and then I'm dividing both sides, but I'm dividing both sides by +2, okay? So we have x greater than or equal to -2. Make sure x comes before the -2, it does, okay? So I plot -2 on the number line. I want to fill in close my circle, and that's a greater than sign, so it goes this way. Now label the graph means you just write the solution, just like you did on the first page. X -2, you're going greater than or equal to because it's closed. Okay, number 6, same thing. If there's only one symbol, so all we got to do is work on getting the x by itself on one side. Okay, so we have negative 2 times x. Well, I need to divide by negative 2, okay? So since I'm going to be dividing by a negative right there, the sign's going to flip, okay? That number, negative 2 I have to divide by, that number I have to divide by is negative right there, okay? So I divide by negative 2, divide by negative 2. Now you have to keep this lined up, okay? 18 divided by negative 2 is negative 9, but you got to line up negative 9 here and put the x where it's at. Now you can't graph that. Okay, you want to graph this, you need to reorder this. So you have x coming before the negative 9, and then you have to flip the sign back. So anytime you reorder it, flips the sign. So that's the final solution. X is greater than or equal to negative 9. Okay, greater than goes this way, so x greater than or equal to negative 9. Okay, next problem, number 7. Negative 3/4 x is greater than 18. So on one side, get the x by itself. This is multiplication. So we need to divide, and I'm going to be dividing by a negative on both sides. So that sign has to flip. Okay, if you're dividing by a positive, it doesn't flip. We're dividing by negative 3/4. It's negative, it flips. Okay, so you have x. 18 divided by negative 3/4 on a calculator is negative 24. So that's in the order we want it. So I put negative 24, circle, less than would go this way. X less than negative 24. That's how you label it, just put it above. Okay, number 8, 5x minus 7 is greater than 8x plus 2. Okay, so only one. Now you got x's on opposite sides, so you can do it the way you do on an equals. You can take out the smaller one. Okay. By the way, when you take out when you have two different x's, that has no effect on the sign. Okay, because I mean you're subtracting. When you're simplifying your x's, the sign needs to drop, whether they be on the same side or opposite sides. So here you have negative 7, and over here you got 3x plus 2. Now I have x on one side of the inequality. We got times 3 and plus 2. So we need to minus 2 first, which doesn't change the sign ever. The dividing won't change the sign because that's positive. Okay. So minus 2, that's going to be negative 9. Keep it lined up. You got to keep it lined up on an inequality. Then you divide by your 3. Divide by your 3. Now the x has to go here for now. Negative 3 to 9 divided by 3 is negative 3. Okay, you need to reorder this before you graph it. You need the x to come first in the sentence, then the value. Then the sign would then flip. Okay, so you got negative 3, and x can be any number less than negative 3. Keep it open. Okay, number 9. 2 times the quantity x minus 8 plus negative 8 inside the parentheses is less than 16 plus 2x. First you have to distribute. When you're distributing, the sign doesn't change. It doesn't matter if it's a negative or a positive. So you're going to drop down your plus. 2 times x is 2x. 2 times negative 8 is negative 16. The other side you get 16 plus 2x. Oh, take out the smaller one. We don't have a smaller one. They're equal. So you take them out. Cross out your number line, and this is all solutions or no solution. Now, it's not whether the numbers are the same, though. It's whether it eats the bigger number, okay? Well, 16 is bigger than negative 16. It eats the bigger number. That's true. So this is going to be all solutions. Okay, number 10. X divided by negative 5 is greater than or equal to negative 6, okay? So, only one inequality. Now, you have divided by negative 5. You got to get rid of the divided by negative 5. Well, you times by negative 5. Now, remember, if you divide each side by a negative, the sign switches. And if you multiply each side by a negative, well, that number I have to multiply by to get rid of its negative. So the sign has to switch. So times negative 5 times negative 5. If that was positive 5, I wouldn't switch it. So you have x in front, negative 6 times negative 5 is 30. and that's the order we want it. So 30, circle fill it, less than goes this way. Okay. Okay, now we're going to get into some compound inequalities. Okay. 10 is less than or equal to 4x minus 5, less than or equal to 15. Oh, we need a number line. But this is called a compound inequality because there's two inequalities. When you run into a compound inequality, you need to make a table. Okay. Okay, so I put each inequality on each side of the table, both the less than or equals. Now here's my inequality. I have a 3 and then 4x minus 5, the whole expression. Now on the other side, I carry that 4x minus 5 over here, and then I have 15. So now I solve each problem separately. Okay. So I have to get the x by itself. So I have to add 5. Sign never changes when you add. When you divide, it's going to be by a positive force, so the sign doesn't change there either. So plus 5 plus 5. So I got 8 and then 4 times x. Now I divide by 4. That's 2 and then x. You need to reorder that. So x greater than or equal to 2. Okay, now don't graph that till you get the other side solved. Okay, you're going to do the same things. You're adding 5, not going to change the sign. You're dividing by positive 4, you're not going to change the sign either because you're dividing by a positive. So I plus 5, that's 20. Then I divide by 4, and you have x and 5. You don't need to reorder that. Okay, now graph them, 2 and 5, both on the positive side. Both the circles are closed, and now you have to look at, you're greater than 2, but you're less than 5, so they come together. Now to label it appropriately, that means the solutions are in between 2 and 5. You put the x, the 2, the 5, okay? Then you want to eat the 5 and eat the x. Don't look over there, okay, for the label on a compound. Okay, number 11, another compound. 6x minus 1 is less than negative 7. 2x plus 1 is greater than 5. Okay. Okay, that's another compound. They're already separated for us, though. You got less than, greater than. So you got 6x minus 1, negative 7. Then you have 2x plus 1 and 5. Now you solve them independently. Okay, you got to add 1, doesn't change the sign. Divide by 6, doesn't change the sign because you're dividing by positive 6. So plus 1, plus 1. I don't care what's over there. Negative 7 plus 1 is negative 6. Divide by 6, x, negative 1. Don't have to reorder that. Okay. Okay, minus 1 won't change the sign. Divided by 2 won't change the sign. 5 minus 1 is 4. So we have x, 4 divided by 2 is 2. Okay, so we got negative 1 and 2. Both the circles this time are open though. So less than negative 1, okay, that should go this way from the negative 1. Greater than 2. Okay, now they go apart, so the way to label that way is or. You just put x2, this way is greater. X, negative 1, this way is less. Okay. Now, absolute value. This is an absolute value bracket. You got the absolute value of x plus 3 less than 5. Okay. Now, absolute value means distance from 0 on a number line. To solve for a variable inside an absolute value, you are going to want to box that up and use D. D stands for distance, okay? Then you're going to want to make a table with the inside of your absolute value on both sides. It becomes a compound inequality, okay? Okay, now, replace this whole thing with D. D less than 5. And you solve for D. Well, I have D by itself. Now, where are the two places you could be 5 from 0? Well, I could be at 5 or negative 5, okay? Now you use the given symbol, the symbol that's there on the positive, but you need to flip the inequality on the negative. This is why you need to flip it. Having a distance less than 5, means you're going towards 0. The distance is getting smaller. Well, I could be going this way, hence less than 5, but I also could come in towards the 0 from this way, okay? Well, when I go this way, that's actually greater than. Now, all you need to do not to overcomplicate it is to just remember to flip the sign on the negative, okay? Then you solve each one separately. So minus 3, the sign doesn't change when you minus or plus. X, 2. Minus 3, sign doesn't change. X, negative 8. Then you graph it and label it appropriately. So you got 2, negative 8. Neither circle's filled in, okay? So you're less than 2, well, which way's less than? Go this way. Greater than negative 8. Okay, so it's solutions are between. So then to label it, you put X, negative 8. Don't look at your table. Okay, right there. Eat the 2, eat the X. I don't need the signs, but that's how that's labeled. Okay, now the next one is absolute value, but they're just equations. They're not something you have to put on a number line. So same thing, just get some practice. Put the inside of the absolute value on two sides, because the absolute value, when I have variable, the absolute value itself could equal actually two things, okay? So D equals 6. Well, solve for D. Looks like it's already solved for it. Equals 6. Now it could be at 6 or negative 6. Now there's no sign there to flip, so you just solve it. You don't graph it on the number line. So X could equal 2. That's a discrete value. And X could equal negative 10. Now, these are not continuous amount of answers. They're just equals. The two discrete answers are 2 and negative 10. Okay, next problem. Well, there's that. Do not distribute. It's not a parentheses. Don't do that. Follow the plan. D. So inside of my distance box, 2x minus 3. Then I remove the absolute value and just put 4 times D. Don't forget the minus 1 equals 12. Now, you have to actually solve for D now. You just add 1, divide by 4. Why am I putting a 12? It's 11, I'm sorry. That's not 12, it's 11. I screwed up. So 4 times D equals 12, divide by 4, D equals 3. Okay, so we have a distance of 3. Well, that could be 3 or negative 3. So now I get X by itself. So you plus 3, 2 times X equals 6, divide by 2, and X equals 3. Okay, plus 3, negative 3 plus 3 is 0, but you just continue on. You still have to divide by 2. This is 0 divided by 2 is 0. So you have two discrete values for X inside the absolute value, 3 and 0. Story problems actually do not take very long on this if you know what you're doing. In a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. You have 42 feet of fence. The width of the garden is 12 feet. Write and solve an inequality that represents possible lengths of your garden. And I want it graphed too. Inequality, you know you need a greater than or a less than. Now when you have, that means less than or equal to, because you can't go over what you have. Okay, 42 feet is what you have. Now go up this little rectangle I drew for you, and we got to put that 12 feet in for the width, because it says the width is 12. So what we're doing with that 42 feet is we're putting it around all the sides, okay? Well, I know I can add the 12s. 12 plus 12. And then I can add the L's. I don't have a value for L. So this is 24 and this is 2L. So I come down here and I write 24 plus 2L, or 2L plus 24. Now solve it. Okay. You're going to minus 24, sign won't change. You're going to be dividing by a positive, sign won't change. So 2 times L, that's 18 divide by 2, divide by 2. L is less than or equal to 9. So you can have the length at 9 or anything less. 0, 9, circle it, less than's this way. Technically on a story problem you can't go over the 0 though, because negatives would not be applied. Label it. Okay, next problem. Average rule. To earn a B in your science course, you must achieve a test average of 86. This is your goal. You scored 86, 85, and 80 on the first 3 tests of the grading period. Write and solve an inequality that represents scores that you can earn on the 4th and final test and meet your goal. Now, if I have to write an inequality based off a goal, I'm going to want to use the greater than or equal to. And my goal is 86. Now, test averages. Average rule, we know we have to divide. Okay, that's how you find average. Now, I've scored 86, 85, 80, and you're like, oh, just divide by 3? No, you're going to take another test and you don't know what you're going to get on it, so that's X. So I'm dividing 1, 2, 3, 4. Now, because I don't know this X, I can't divide, okay? So what I do is I just come down here and I put 4, I put the X, and then I add the 3 tests I've already taken, but I don't divide. I just set it right there because I can sum up the test I've already taken. So 251. Now to solve this, you have division across the whole side, so you have to times by your 4 first, and then you need to minus your 251. So you're timesing by a positive, the sign doesn't change. When you minus, it's not going to change either. So you actually have to get rid of the divide by 4 first. Okay, so X plus 251. Don't forget you got to take 86 times 4. 2, 3, 44. Then you just subtract 251, and that's 93. Okay, go ahead and graph it. Greater than goes this way. Okay, now the last problem, this is not a hard one. The length and width of a piece of metal can vary by at most half a centimeter from the desired amount. Desired length is 6 inches, desired width is 20 inches. Write inequalities that represent the range of the length and width. Range is going to look like this. You're going to have a maximum and a minimum, okay? Range. So length and width, make a number line first. You're not going to use 0. You don't have a length of 0. This is the minimum, this is the maximum. This is the minimum, this is a maximum. Now, what's your length supposed to be? The length is supposed to be 16, but it can vary by 0.5. So you add and subtract 0.5. And then the width is supposed to be 20, but I can again vary by 0.5. That means you can go higher by 0.5 or lower. Now 16 plus 0.5 is 16.5. Then we take 16 minus 0.5 and that's 15.5. Now graph it correctly because you can be equal to those amounts and anything in between. So you put L for your variable. Remember, this has to be numbered like this right there. L is a variable instead of X. So L is between them, so we use double less than's, equals, equals. So I put a number between them, it should eat this and that, and then the L. Okay, width, okay, 20 plus 0.5 is 20.5, 20 minus 0.5 is 19.5. Connect them, use W for your variable. 20.5, 19.5. That is always how you represent a variable that's in between two numbers, like that.